So this is factorizing 8x cubed plus 64. I know that it's in the form of x cubed plus a cubed, which equals 2, and I'm going to follow the formula from here, where that equals to x plus a bracket x squared minus ax plus a squared. So we've actually done this before. We've looked at these formulas and we haven't actually used them as much. The only thing is, because I know it's in the form, I can kind of shove it into that formula in order to get an answer. So first things first, I want to go ahead and identify what can I make this in terms of something all cubed. So I know that if I just do x cubed, that's not going to give me 8x cubed. So what number do I have to put in here to get 8x cubed? 2. Easy. So what I'm going to do is I'm going to rewrite this equation, and instead of writing 8x cubed, I'm going to write 2x all cubed. Do we agree that's the same thing? Awesome. Same thing. What number cubed gives me 64? 4. Same thing. I'm going to put that into the formula, and I end up with 2x plus 4. And all I've done is I've identified, I'm going to try and use the color you guys can see up the back. I've identified that this is my x, and this is my a. So anytime I see x, I'm actually writing 2x. Anytime I see a, I'm writing 4. So I'm substituting that in. I get 2x there. I get bracket 2x squared minus 4x plus 4 squared there. Have I lost anyone? Okay, that normally means yes. So what I'm doing is substituting those values in. I'm going to go ahead and simplify that. So I get bracket 2x plus 4 bracket 4x squared minus 4x plus 16. Now, is that fully factorized? Why not, Helen? Good. Let's take out a number. What number goes into both of these? 2. I'm going to take it out. What number goes in all of these? 4. I'm going to take them out of each respective bracket. So from there, I'm going to go ahead and take the 2 out, and I get x plus 2. And then over here, I get 4. And then x squared minus x plus 4. Okay? And from there, I'm just going to go ahead and combine those two values. So 2 times 4, instead of writing 2 and 4 separately, I'm going to write 8 bracket x plus 2, x squared minus x plus 4. Now, arguably, you could continue doing this. Now, x squared minus x plus 4, if I look on that side over here, you could go ahead and do complete the square. It is a quadratic equation after all. However, I can't actually see a method that ends, it gives me something that's more simplified than this, so I'm going to stop there for now. And this is a level I'd be expecting for the assessment for chapter 6. So you don't need to continue from there, but this is what I'm expecting for now. Any questions? No? Alright, so I'm going to start moving on to exercise 6D. If you need to copy the stuff down from that do now question, please feel free to do so. Now, 6D, a lot of it is actually using skills you already learned in quadratic equations. So please make sure you are familiar with the concept of null factor theorem and factorizing polynomials. In this case, we've got an already factorized polynomial, pretty straightforward. All we need to do is apply understanding of null factor theorem. So, as per usual, I'm going to cross these out, ignore those two. What is x equal to? X equals 2. Good, negative 3. Now I ignore these two. What's x equal to? Negative 1. Good. And lastly, if I ignore these two, x equals to negative 2. That's it. So we apply null factor theorem. It applies in all situations. Sorry, my apologies. It's just 2. We apply the same understanding of our quadratic equations, solving those into solving cubic functions. Thank you for pointing that out. Alright, that was a fairly simple one. Let's move on to something that's a little bit more difficult. So, solve 2x cubed minus x squared minus x equals 0. What is the key defining feature, the difference between this question 2 and question 1? Powers? Yeah, the powers are different. What else? It's not in factorized form, which means that we have to factorize it ourselves. How might you factorize this one? Once again, there's easier and harder way. Sorry? So you mean using the remainder theorem and then guessing and then finding the factor? Yeah, you could do that. Or I could just start by finding something that's in all of these terms. X, easy, let's take it out. So I'm going to write X. I'm hearing a lot of chat up the back. Can we please keep it down? Thank you. So I get X bracket 2x squared minus X minus 1. Now let's focus on this. Is there a way we can simplify that? Or factorize that, sorry. Let's use cross method. I know you guys don't, some of you guys don't like cross method. Let's just use it for this example. So I get 2x over here and x over here. So two values that multiply to give me 2x squared. And now I'm looking for two numbers that multiply to give me negative 1. That add to negative 1 if I put that into this cross method. So I'm going to go ahead and put positive 1 over here and negative 1. Do we agree that they both multiply to give me negative 1? Easy. Now I'm going to go ahead and continue this. 2x times negative 1 gives me negative 2x. That gives me positive 1x. Does that give me negative x? Perfect. So we're going to use these. I'm going to follow along these lines over here. You guys remember cross method generally, right? Okay, good. So I get bracket 2x plus 1 bracket x minus 1 equals to 0. Am I done? Is that right? What's wrong with that? Thank you. That right here was what we got from that factorization. We still have that x on the other side, so I'm going to write x there. Now, do I need to have these brackets over here? No, it's still all multiplications. I can get rid of those. So, from here, now I just use null factor theorem. If I ignore and I get rid of these ones over here, what is x?
1.
X is positive 1. Thank you very much. What happens if I get rid of both of these? X equals 0. Now that is the one that most people make the mistake of forgetting. Please don't forget that if x is by itself, x equals 0. Now, over here, 2x plus 1 equals 0. What do we get?
Negative half.
Good. If you wanted to, you could write out 2x plus 1 equals 0 and solve from there, or you can just write negative a half. Perfect. Pretty straightforward. Any questions? No? Okay. Last question, question 3. So we have to solve 2x cubed minus 5x squared plus 5x minus 2, which equals to 0. Now, we have to look at it and think, is there an easier way of solving this? As in easier in terms of using formulas, or whether we can just factorize by shortcuts, anything we can do? I can't personally see one. And so from there, now I'm going to go ahead and use the long method of finding a factor by using the remainder theorem and then substituting just long division, etc., etc. So we know that whatever value it is, it has to be a factor of negative 2. So someone list me factors of negative 2. Negative 2.
1, 2.
Positive 2. 1.
Negative 1.
Easy. That's it. Those are the only 4 options it could be if it's a whole number. Remember, just vaguely, rational root theorem, if it's not one of these, it has to be a fraction. But in this case, assuming it's a whole number, it has to be one of these. So, let's pick one.
Negative 2.
Pick a different one.
2.
Pick a different one.
1.
Positive 1. Wow, positive 1. That's great. Let's do that. X plus 1. So, if it's x plus 1, I have to sub in what value? Oh, sorry, not x plus 1. Sorry, I meant we're subbing in positive 1. My apologies. If we're subbing in positive 1, then I go ahead and substitute. Every time I see x, I put in 1. So 2 bracket 1 cubed minus 5 bracket 1 squared plus 5 bracket 1 minus 2. It should theoretically, if it is a factor, it should give me 0. Awesome, that's a factor theorem. So I'm going to go ahead and do that. So 2 times 1, that's 2 minus 5 plus 5 minus 2. Automatically, I can see that equals 0 because these two cancel and these two cancel over there. Perfect. So if P of 1 gives me a 0, what is the actual factor, or what is the actual equation? I let 1 equal to x, and then I move it. So I might say, let's minus 1 on both sides. 0 equals to x minus 1. That is the factor. Am I done? Why not? What do I have to do now? Thank you. I have to solve it. So let's do long division. right? The thing I mentioned earlier, last lesson, but only to a few people, unfortunately. The difference between finding the remainder using the remainder theorem and finding the remainder using long division is that you don't get the quotient when you divide it or try and find the remainder using the remainder theorem. So if you want the quotient, in which case we do, you have to use long division. So I'm going to write out those questions over here. So that is 2x cubed minus 5x squared. That's a terrible 5. There we go. Minus 5x, plus 5x minus 2. And that's from this over here. And then we'll go ahead and divide by our divisor, which is x minus 1. Any questions so far? Okay. What value do I have to multiply x by to get 2x cubed? 2x squared, thank you very much. I'm going to write 2x squared. So I write 2x cubed over here because 2x squared times by x gives me 2x cubed. And then I also have to multiply negative 1 by 2x, which ultimately gives me negative 2x squared. And remember, implied subtraction. So 2x cubed take away 2x cubed, we know is 0. Negative 5x squared minus negative 2x squared gives me negative 3x squared is correct. I bring down the 5x, and I get plus 5x over here. What value do I have to multiply x by to get negative 3x squared? Negative 3x, and write negative 3x over here. So I get negative 3x squared, because that's what I get when I multiply these two values over here. But now I'm going to multiply those two, and I get positive 3x. Am I going too quickly? Okay. Hopefully we're quite familiar with this concept of long division. So I'm subtracting those, obviously. So I get negative 3x squared. Take away negative 3x squared gives me 0. 5x take away positive 3 gives me 2x. Thank you very much. Positive 2x. I bring down the negative 2. What value do I have to multiply x by to get 2x? Obviously 2. So I'm going to write plus 2. And that gives me 2x minus 2. Ultimately, that gives me 0. Which means we've done it two different ways. We've done it through remainder theorem and long division, and we still get 0 remainder, which means it's definitely a factor and we haven't messed up. So that means that 2x cubed minus 5x squared plus 5x minus 2 is actually the same as, and I'll write that over here, x minus 1 times 2x squared minus 3x plus 2. Any questions about that? No? Okay. So now I have to remember that, well, it says in the question over here that whatever that equation is equals to 0. And therefore I can solve it. So I'm going to go ahead and write equals 0 over here. Immediately, using null factor theorem, what is one of the answers? 1. X is 1, because if I ignore that, I get x minus 1 equals 0, which gives me x equals to 1. Now 2x squared minus 3x plus 2. What would we normally do from here? Sorry? We would just factorize it and then go ahead and use null factor theorem again. However, I'm going to actually just check how many answers there are. Do you guys remember what method do I have to use to check how many answers there are in a quadratic equation if I let y equals 0? Starts with D. Thank you very much. Discriminant. What's the formula? Thank you very much. So discriminant equals to b squared minus 4ac. I'm pretty sure I heard Eminem say that in the back. So I'm going to identify b is negative 3, a is 2, and c is positive 2. Any questions about that? Okay. Discriminant equals to negative 3 squared minus 4 times a, which is 2, times by c, which is also 2, and I get 9 minus 4 times 4, which is 16. That is obviously a negative number. Is that negative 7? Yeah, negative 7. If the discriminant is a negative number, what does that mean? How many solutions do I have? There are no solutions, because remember in the big old quadratic equation formula, that square root is on top of that discriminant. If the discriminant is in the square root and it's a negative number, it doesn't exist. There are no negative numbers that you can square root to give a number. So, in which case, I know that this, whatever this is, has no solutions. And therefore, remember those 3 dots that look like, I don't know. Those 3 dots mean therefore. So therefore, x equals to 1 is the only answer you have. So it is possible to, even though you have like multiple of these equations that make up that cubic function, it's possible to have one that only has one solution, or two solutions, or whatever it is. And later on in this unit, we'll talk about why that is the case. Any other questions? Sweet, awesome. So